Hello and welcome to the ENCOM Wireless Broadband Mesh presentation on concepts and design considerations. During this presentation, we will talk about four key topics here: the terminology that's associated with mesh, the characteristics of mesh radios, and most importantly, design considerations and the network examples that we will go through. When we talk about a mesh network, there are actual radios that make up this mesh network here. From the picture shown in here, this is what your typical mesh node will look like. Multiple mesh nodes will link together and will create your mesh network. Now, a mesh node can either have one or two radio cards installed inside of it. This will be dependent upon your design for your mesh network. The following picture here does show us a couple of examples of how you can have mesh nodes with one and two cards and the antenna options that are available to us. For example, in the bottom left-hand corner, we do have a mesh node with a panel antenna as well as an omni antenna. Up in the middle, we have the mesh node with two dual panels. And to our right, we do have a mesh node with just one panel antenna, which will correspond to one radio card. The next concept to understand is that of a mesh gateway. When you have a mesh network, you are going to need one of those radios to be a gateway back to your traffic operations center. Physically, the radio still looks the same. It is only the programming that changes on the radio to make it from a regular mesh node into now a gateway. We will go into more detail of the mesh gateway later on with the network examples. There are four important characteristics to understand with mesh radios. The first one is that these mesh radios are self-configuring. Now what this means is if you're going to send data across this mesh network, this data is going to find the best possible path to take in order to get to its destination. The second characteristic is that of the mesh network being self-healing. Say for example you do have a mesh network and we do lose one of the radios on the network. What will happen is the rest of the mesh network will reconfigure itself in order to establish a new connection between the radios themselves in order to accommodate the loss of this one radio. The third characteristic to understand is that of gateway redundancy. Now, from the previous example, I described what a gateway does. In a mesh network, you can have multiple gateways or exit points out of a particular mesh network back to your traffic operations center. The fourth characteristic to understand is that of redundancy. As mentioned previously, with these mesh radios, you can have one or two radio cards that can offer redundancy upon your network. Again, this is very much determined upon the design that is required for your mesh network. Next, we'll get into the network planning of a mesh network. Before we get into the details of complexity, site selection, antenna selection, and all the other various components that make up a mesh network, I want to stress that it is extremely important to understand what it is you are trying to achieve with your mesh network. Are you more concerned about redundancy, or are you more concerned about having a huge amount of bandwidth? Understanding what you want from your network will go a long way in determining whether to go with a mesh network or with a... Again, the key component here with the mesh network is to plan, plan, and plan some more. The better plan and design that you have going forward, the less limitations and greater understanding you will have as to what your network can and cannot do. Now, there are 6 main components that deal with network planning of a mesh network. The first one is going to be your network complexity. Are you going to have a small mesh network or very much a large mesh network on there? The second thing, again, will be deciding upon the number of radio cards per your mesh nodes. The third component would be the frequency bands that we're going to be operating in, either 5 gigahertz or 4.9 gigahertz, followed by our antenna selection, as well as site selection, and having proper frequency separation between each of these mesh nodes. It is also recommended for additional information to go to www.encomwireless.com and download the Industrial Wi-Fi WiMAX Mesh Design Guide manual. The second thing to do is to also contact your local ENCOM sales representative with further assistance on mesh designing. With the system complexity of a mesh network, as I mentioned, it can either be very simple or it can be a very sophisticated mesh network that you're going to be getting into. Some of the things that you're going to have to take a look at with the complexity of the network is what sort of coverage am I looking at? Is it just going to be a couple of square miles, or am I looking at a very large deployment for my system here? The next thing would be on your concentration. For example, are you going to have only a couple of nodes per gateway, or are you going to have a very large network with multiple gateways on there in order to be accessed by the traffic operations center? The type of data that you're looking at as well is also very important. If you're only looking at simple telemetry data or any sort of controller data, very minimal bandwidth related items, you'd be dealing with a simple mesh network. When you start to look into things with voice, video, something that uses much more bandwidth, you're going to be dealing with a sophisticated network. And as you can see, that also relates to our bandwidth requirements of either needing very low bandwidth or very high bandwidth. Now, when dealing with mesh complexity, it's always important to take a look at this chart, and if you're even uncertain as to what sort of system you're going to be having, either a simple or sophisticated, it's always best to err on the side of caution and go with a sophisticated network. Therefore, you do have enough movement and flexibility in your design of the mesh, and you're not going to be limited to by a smaller mesh network. When you're looking at your antenna selection, it's important to decide upon whether you're going to be needing an omnidirectional antenna or more of a directional antenna. Use the chart below in order to help understand whether or not your system will be using omnis or more of a directional antenna. Keep in mind that you can also have mesh networks which are going to have a combination of the two together. When you're choosing a mesh node site, you'd always want to have locations that do have good line of sight to your neighboring nodes. You'd need to ensure that your Fresnel zone is free of buildings, structures, or any obstructions that can affect the communications on there. You also want to ensure that you're also in an area which is not going to be highly susceptible to other forms of interference out there. For example, if you are in a highly populated area which uses a lot of 2.4 radios, you'd want to definitely stay out of that frequency spectrum. You'd also need to choose locations that are mounted at the highest possible location such that we're not interfering with our Fresnel zone. The most importantly, it is always recommended to perform a site survey for each of these locations, as truly a site survey will help you understand if this location is going to be a viable option for you. The following picture shows the concept of the Fresnel zone. For this particular example, we have selected appropriate frequencies for each of our endpoints. The Fresnel zone is going to be this football-shaped path in between two nodes. Notice that the closer you are to your node, the smaller your Fresnel zone is going to be. So if you're going to start to have longer distances in between your two nodes, your Fresnel zone is going to get larger. This is why we would always aim to obtain to have the highest height possible, as well as a clear line of sight such that we're not interfering with our Fresnel zone. As you can see in the picture, there are trees in the way, but they are not blocking a significant portion of our Fresnel zone. Always trying to maintain a clear line of sight on your site selection. We will now start getting into network examples with the mesh radios. For this first example, we will deal with a pocket deployment. From the example, you can see that we are going to be using multiple mesh radios with one radio card on there. They're going to be talking in a mesh configuration, and our exit point out of this mesh configuration is going to be our gateway radio that is shown in blue. In this particular example, we are still dealing with a pocket scenario, but in this instance, we're going to have multiple gateways or exit points out of that particular mesh network, which will communicate back to our traffic operations center. This is specifically just designed to show that we can have more than one exit point out of a particular pocket. Now let's take a look at an example where we start to group together multiple pockets here. So for this particular example, we do have 3 pockets of mesh radios, and each of them are going to be isolated such that there's going to be unique SSIDs as well as frequency selection per pocket. However, all 3 of these pockets are going to be part of the entire mesh network. As we start to add more and more pockets together, you can start to see it becomes a bit of a honeycomb pattern to it. But notice that each of these tiled pockets are going to have a unique frequency denoted by either A, B, or C, and it's not going to interfere with any of its neighboring pockets. As you can start to see, you can have other combinations of mesh networks. For example, this particular one is of a simple loop. We are going down certain corridors of a city, and it's creating one big loop here. You can have the mesh set up such that there is some redundancy on the endpoints. And as you can see, we still have our one gateway radio, which is going to be our exit point out of this particular mesh network, which will communicate back to our traffic operations center. You can also have a mesh network which is going in a straight line, for example, down a city corridor. As you can see in this particular example, we can also have one or multiple gateways, which again are exit points for our particular mesh network. So we've gone over a pocket configuration as well as tiled pocket configurations and some standard loop configurations for our mesh radios here. But the question remains is, say for example, we do have that tiled pocket or multiple pockets. How do we connect these pockets together? Well, that's where the concept of an intertie comes into place. So with an intertie, it can be a mesh radio with two radio cards as shown in this particular example. Radio card number one will have frequency A, which will be communicating to loop number one. And radio card B will have a frequency which is going to be communicating to loop 2. This is the concept of an intertie and how we tie in together multiple locations into our mesh network. So using the concepts that we've learned from the mesh presentation so far, let's take a look at a set of Google points here and determine what course of action we take in order to design our mesh network here. So for this particular example, we have our traffic operations center, and we have 8 intersections out there that we've determined that we would like to use a mesh network on. Now, also for these 8 intersections, we would like to bring back video to our traffic operations center. At each of these locations, there's only going to be one camera, and we will say that each of these cameras are going to bring back approximately 1.5 to 2 megabits per second of video. So the question remains, what do we do in order to design our mesh network? So let's take a look at the network complexity. Yes, it is a smaller mesh network, but on the other hand, we are bringing back video, so we can consider it a complex network. For each of these mesh locations, what sort of radio cards would we end up using? Either a mesh node with one radio card or with 2 radio cards. For this particular example, we will have 2 radio cards being used at each of these mesh locations. Why is that? Well, since we're on a corridor here, we can't reach some of these locations just because there's some trees in the way and so forth. And again, we haven't really experienced too much of the mesh radios with 2 radio cards, so we're going to use that for this particular example. These 8 mesh radios can then be linked together in a mesh network, and they will have a unique frequency and SSID associated to them. The last thing will be, which of these radios would you make into a gateway radio to exit out of that mesh pocket and talk back to our traffic operations center? Now, the rule of thumb with a gateway radio is we would like to make it such that in our pocket we're minimizing the amount of hops necessary for data to get out of the network. So say for example we made mesh node 8 a gateway radio. If you're taking a look at the data that's going to be flowing from mesh node 5, it would have to take 1, 2, 3, 4 hops in order to get out of the mesh network into our traffic operations center. Now 4 hops is acceptable. We normally recommend 3 to 4 hops for data to get out of the mesh pocket via the gateway. However, for this particular example, a better choice for us, since we do have a clear line of sight, would be to use mesh node 2 as a gateway. Once you take a look at each of the other mesh locations, it only needs 1, 2, or just 1 hop to reach its gateway in order to get out to its traffic operations center. If you'd like to learn more or have any questions, please visit us at www.encomwireless.com. Thank you.